Picture an AI assistant that can write, reason, and explain almost anything. Now ask it to check your calendar, read a file on your computer, or look something up in a database. For a long time, the honest answer was, it would love to, but it cannot reach any of that. The model lived in a box, and the deeper problem was the wiring. Every time you connected an assistant to a new tool, someone had to hand-build that connection, one at a time. With many AI apps on one side and many tools on the other, that becomes a tangle nobody can maintain. As the company that started this put it, every new data source required its own custom implementation, which made truly connected systems hard to scale. This video is about the thing that untangled it. It is the Model Context Protocol, or MCP, and it is how today's AI agents reach out and actually touch the world. Let us see what it is, how it works under the hood, and where it can quietly go wrong. So what is MCP? In the words of its own documentation, it is an open standard for connecting AI applications to external systems. Read that carefully. It is a standard, a protocol, a shared agreement about how two sides talk. It is not a model, it is not one app you buy, and it is not one company's private interface. It is a set of rules with free open-source toolkits that put those rules into practice. Through it, an AI app can reach data sources like your files or a database, tools like a search engine or a calculator, and ready-made workflows. The builders have an official analogy worth borrowing. Think of MCP like a USB-C port for AI applications. Just as USB-C gives one standardized way to connect electronic devices, MCP gives one standardized way to connect AI apps to external systems. Before a universal port, every device had its own oddly shaped plug. After it, one shape and everything fits. The plug is the point. A little history, because it matters for getting this right. MCP was introduced and open-sourced by the AI company Anthropic in late November of 2024. It was created by two of their engineers, David Soria-Para and Justin Spar-Summers, and announced as a new standard for connecting AI assistants to the systems where data actually lives. Not 2023, and not by some other lab. And they did not just publish a document and walk away. On day one, they shipped three things together: the specification itself with software toolkits to build on, support for running these connections locally, right inside their desktop app, and an open collection of ready-made connectors for things like file storage, chat platforms, and code repositories. Several other companies signed on as early partners, so this was never a proposal on paper. From the very first day, it was something real you could pick up and use. Now the central idea, the one to really hold on to, because it outlives every version number. Say you have a number of AI apps, call it N, and a number of tools, call it M. Wire each app to each tool by hand. And the number of custom connectors is N times M. 10 apps and 10 tools is already 100. Every new app taught about every tool. Every new tool rebuilt for every app. That is a combinatorial explosion, the tangle from the start of this video. The fix is beautiful in its simplicity. Put one agreed protocol in the middle. Now a tool builder writes one connector that speaks the standard, and every AI app can reach it. An app builder writes one connector and reaches every tool. The math collapses from N times M down to N plus M. Build once, integrate everywhere. The messy web of one-off cables becomes a clean star around one hub, and this is a proven pattern. USB did it for peripherals, the web's protocol for documents, the shipping container for freight, and a standard called the Language Server Protocol for code editors, whose ideas MCP openly borrows. A thin universal interface in the middle, so the two sides evolve on their own. The pattern is the lesson. MCP is just its current name. So why does this belong in a series about how AI works? Because MCP is the plumbing that AI agents reach the world through. Remember what an agent really is. It is a loop. The model thinks, calls a tool, reads the result, then thinks again until the job is done. That ability to call a tool already had a name before MCP existed, Anthropic calls it tool use. Others call it function calling. Either way, it is the verb, the act of reaching out. What MCP adds is the standard socket that makes that verb portable across any model and any tool. And the benefits land on everyone. Developers spend less time building integrations. The apps gain a whole ecosystem of data and tools, and end users get assistants that can reach their data and act on their behalf. An agent that reads your calendar to plan your day, turns a design into a working app, connects to several databases at once. In every case, the act of reaching out passes through the MCP socket, and the result returns the same way. Let us get specific about what an AI can reach, because there are three distinct things and people blur them into one. The first is tools, actions the model can actively take. Query a database, send a message, create a calendar event, change a file. Each is one operation with defined inputs and outputs. The second is resources, passive, read-only data the app pulls in for context. A file's contents, a database's shape, a page of docs, each with a unique address and a type. Tools push actions out, resources pull information in. They are opposites. The third is prompts, reusable workflow templates a user deliberately invokes, like a saved Plan My Vacation command. And here is the payoff of all three combining through one interface. A travel assistant with three connectors behind it for bookings, weather, and your calendar and email. You fire one prompt. It reads resources for context, then chains tools across all three connectors. It searches flights, checks weather, books a hotel, makes a calendar event, sends a confirmation. A task that could take hours, done in minutes, with no custom integration built for that exact mix. Now under the hood, the heart of this story. MCP has three participants, and naming all three correctly is the most important thing to get right. The host is the AI application itself, the thing you use like a chat assistant or a coding tool. It holds the model and the conversation and coordinates everything. The client is the part people miss. The host does not talk to a connector directly. For each connection, it spins up a dedicated client whose only job is to maintain one link to one server. 4 connections, 4 clients, each a separate one-to-one line. The server is the program that exposes the tools, resources, and prompts. So the shape is one host holding several clients, each running its own cable to its own server. Do not confuse the host and the client. The host is the whole app. The client is just one of the plugs it creates. And one more thing people get wrong. Server does not mean a faraway machine. It means the program that serves the capabilities wherever it runs. Very often that is right on your own computer with no network at all. Other servers live out on the network with secure sign-in. Both plug into the same socket shape. Now watch a session come to life, because this is the moving part. There are 2 layers. An inner data layer, the meaningful conversation where messages travel as small, structured, plain text packets. And an outer transport layer which just moves the raw bytes through a direct local channel on your machine or over the web for a remote server. Same letter, different envelope. The session has clear steps. First, a handshake. The client says, "Here is the version I speak and the features I support." The server replies with its own. They find common ground, and if there is no compatible version, the connection closes. Second, and this sets MCP apart, discovery. The client asks, "What tools have you got?" The server lists each tool with a name, a description, and a precise schema of its inputs. The host merges tools from every server into one registry the model can see. The old style hard-coded that list in advance. MCP flips it. The model discovers tools at runtime live. Third, the call. When the model picks a tool, the host sends a call message with the name and arguments checked against that schema, and the server runs the real code and returns a structured result, which flows back as new context. Think call, read the result, think again. And fourth, the toolset is not even frozen. If a server's tools change mid-session, it sends a one-way notification, and the client refetches the list. Tools can appear or disappear while you work. Now a subtle detail almost every explanation flattens. Those three things a server offers each have a different controller, a different hand at the wheel. Tools are model controlled. The model decides when to call one based on what you asked. Resources are application controlled. The app decides which data to load into context, not the model on a whim. Prompts are user controlled. They only run when you, the human, deliberately invoke them, so it is not all the model doing whatever it likes. The model drives the actions, the app curates the data, the human triggers the workflows. 3 lanes, 3 drivers, and there is a quiet symmetry. The channel can run the other way. A server can reach back and ask the host's model to generate something, so the server itself stays model independent, or pause and ask you for a missing detail or a confirmation. The conversation flows both directions. But for everyday understanding, those 3 server offerings with their 3 controllers are the main event. Flattening them all into the word tools is the most common way people misunderstand MCP. This is the most important misconception to clear up, so let us be precise. MCP did not give AI the ability to use tools. Models could already do that through the feature called tool use or function calling. That is the model's built-in talent for emitting a structured request that says, call this function with these arguments. So what does MCP add? It standardizes that ability. Think of it in 2 phases. Function calling is phase 1, the model forming the intention to act, deciding what it wants to do. MCP is phase 2, the standard infrastructure that carries that intention out to any tool the same way, no matter which model or company built it. In fact, MCP uses function calling underneath. It does not replace it. So the clean mental model is this. The model is the brain. Function calling is the brain forming the intention to act. And MCP is the universal nervous system and socket that carries that intention out into the world and brings the result back. Same wiring, no matter the brain, no matter the tool. So how does MCP sit next to the alternatives? Compared to raw function calling on its own, the difference is discovery and portability. Plain function calling needs a hard-coded list of functions, wired separately for each app, and each provider expects that list in its own slightly different shape. MCP adds live discovery, one uniform interface across providers, the ability to add and remove tools on the fly, and those extra resource and prompt offerings function calling never had. One way to say it. Function calling handles a single tool request. MCP manages how tools are found, connected, and run at scale. Compared to a plain web API, the tool's underlying ability is usually still a normal API. The MCP server is a thin adapter that wraps it in the one shape every AI app understands. An earlier, single-vendor attempt called plugins pointed this way, but MCP is the cross-vendor open standard that took hold. And one neighboring idea is worth a mention. MCP standardizes how an agent talks to tools and data. Separate, emerging standards aim at how agents talk to each other, a different layer, meant to work alongside MCP, not against it. So how do you get this, and what does it cost? The protocol itself is free and open source. The specification and the official toolkits cost nothing. What you do pay for is 2 things. First, the model. Every tool description and every tool result becomes extra text the model has to read, and you pay for the model's usage by the amount of text it processes, so a big pile of tools adds up. Second, any paid service that happens to sit behind a particular tool. As for using it, you do not build anything yourself. Your AI app adds servers, either small local ones it launches on your machine, or remote ones it connects to with secure sign-in, and it automatically merges their tools into the model's registry. MCP is supported across a wide range of apps now, from chat assistants to code editors. And if you are a builder, here is the magic line. Write one server and reach the whole ecosystem. Thanks to that shared standard, there are now thousands of MCP servers out there, and the number keeps growing. Now the part a one-stop explainer must not skip. The moment you give an AI hands the power to write files, send messages, and hit live services, you create a real security surface. This is not a reason to panic. It is the natural cost of letting software act, which is exactly why the protocol leans so hard on consent. 3 documented kinds of trouble. First, and biggest, is prompt injection. Malicious instructions can hide inside a document, a database row, or even a tool's own output. The model reads that text and gets hijacked into doing the attacker's bidding instead of yours. It is consistently ranked the #1 risk for this whole class of applications, and there is a documented case where an agent processing support messages treated attacker text as commands, while running with broader access than it should have. Second is tool poisoning, sometimes called a rug pull. The model does not truly know what a tool does. It only knows what the description claims. So an attacker can hide instructions in that description or register an innocent tool, get it approved, then silently swap in a poisoned version mid-session, turning that live update feature against you. There are formally cataloged vulnerabilities of exactly this shape on record. Third is overbroad access, the confused deputy problem. A tool with wide permissions does more than intended, or a connector acts with its own authority instead of yours, so the gate never checks who is really asking. Here is the reassuring part, and it is deliberate. Human oversight is built into the design, not bolted on afterward. The guiding principle is that tools are model-controlled but user-overseen. The model proposes, the human disposes. In practice, an app shows you an approve or deny dialog before a tool with real consequences fires. You can switch individual tools on or off, pre-approve safe operations, and review a log of everything the agent did. That little approval prompt before an agent sends an email or deletes a file is not friction for its own sake. It is the safety valve, sitting where the power is. But be clear about what MCP is and is not. It is plumbing, not intelligence. It standardizes the connection. It does not make the model smarter, and it does not judge whether a tool call is wise. A weak model with brilliant tools is still a weak agent. The socket faithfully carries whatever the brain decides. And this is all young and moving quickly. The protocol is versioned by date and updated often, so treat the exact feature list as a moving target, and the core idea, the standard socket itself, as the durable thing. Let us retire the common myths in one quick pass. MCP is not what finally let AI use tools. Models had tool use before it. It did not replace function calling. It standardizes it and uses it underneath. An MCP server is not always a remote cloud service. It is very often local on your machine. MCP is not an API or a model. It is a protocol, a set of rules. It is not just tools. It is 3 offerings with 3 controllers. And it did not make your agent safe by itself. It opened a real attack surface and handed you the locks to manage it. Now the meaning. The clearest sign of what MCP became is who adopted it. Within months, the company's biggest rivals took up the very same standard, and then it was handed to a neutral foundation to govern, the way a public road belongs to everyone who drives on it. The durable takeaway is that MCP decouples capability from connectivity. The model brings the intelligence, the protocol brings the reach. Any model can talk to any tool, and any tool written once serves every model. We began with a brilliant assistant in a box, surrounded by hand-built cables. We end with one universal socket and a clean star of tools radiating out. That collapse from n times m down to n plus m is the whole story. Tool use is the verb. MCP is the standard socket that carries it out to any tool and brings the result back. The same wiring no matter the brain or the tool. That is, quite literally, how an AI agent reaches the world. Just remember the one honest caveat. Hands come with locks. The power to act and the responsibility to oversee it arrive together.